All right, in example 2, if you have not yet put the data into your calculator, please do so. The age of the cars should be put into list number 1, and then the trade-in value, and do notice that that's in thousands of dollars, but again, just enter them as the numbers that are there. Put those in L2. For the first part, you're supposed to create a scatter plot. There are only 8 points here. It's not that difficult to create a scatter plot with 8 points on it if you want to real quick sketch one out. And I'm going to make like a really rough sketch here. You would put your age along the bottom, and then you would put the value of the car as the y-axis. And obviously, you know, you would do some scaling, so like 2, 4, 6, 8, 10, etc. But if you do want to know, or if you have a large data set that you don't want to plot by hand, I do have the instructions there. The first column is how you would go ahead and get to the point where you would put stuff in. So you hit second and then y equals. Just a note on that, the y equals button is the first button directly underneath your calculator screen, okay? Then you'll choose number 1, press enter, and then that will send you to a screen where you get to have some options. So make sure on is selected, pick your type of graph, and so pick the one, it should be the very first one, looks like a little scatter plot. Where you put your x values, probably L1, where you put your y values, again list 2. For the mark, I would recommend either the little square or the plus. The dots can be kind of hard to see. And then if you have a calculator that has color as an option, you can pick whatever color you want. Not everybody has color, so ignore that if that's the case. And then you'll press zoom, the third button directly under your calculator screen, and then press 9, which should be zoom stat. And it will take you to a scatter plot, and it scales everything exactly the way you need it to be based on your data. So what I'm going to do is I'm just going to really quickly like kind of put here what this data sort of looks like whenever you plot it, like rough, really rough, okay? And then it says, does there seem to be a linear relationship? I'm hoping you say yes, and then if so, describe it. And so I would describe this again as fairly strong or maybe strong. And since we're going downhill, this would be a fairly strong or strong, again, take your pick, negative linear relationship, okay? And again, right now it's your opinion. So you can use whatever adjectives you want to describe the strong versus fairly strong. Just make sure you've got that it's negative in there. All right, to find the linear correlation coefficient, remember that is the R value. And since this is again a new command for us, so that's stat, arrow over to calculate, and then look for LINREG plus B, probably number 4 or close by. The linear correlation coefficient should be calculated as negative 0.933. All right, and then what does that tell you about the linear relationship? Well, the negative means it's a negative linear relationship, so we got that part, okay? The size of the number, 0.933, since that is very close to 1, we have actually a really strong negative linear relationship, okay? So since 0.933 is close to 1, we can say there's a strong negative linear relationship, doing a lot of abbreviating there, between the age of a car and its trade-in value. Okay, and again, if you also want to say because negative 0.933 is close to negative 1, that would be the same result. Okay, so again, you can kind of take your pick on that. Find and interpret the coefficient of determination. So remember that that is the R squared value. So for R squared, we get 0.871. And then what does that mean? So again, writing this as a percentage, 87.1% of the variation in, and we want the Y variable here, so that would be trade-in value, can be explained by our X variable, which is the age of the car. Okay. All right. Moving on to part D, and still working off of the same screen that you had before. So find the regression line. So remember, we want to do a Y hat, and then round all parameters. That just means the values, okay, the numbers, to 2 decimal places. So we should be at negative 1.72x plus 21.40. Okay. Interpret the slope. So the slope is that negative 1.72, the coefficient of x. And so what that would mean is for every additional increase in x, so that's year. So for each year older a car is, okay, so our unit is a year older, okay, so for every additional year a car is, in terms of its age, the trade-in value. Now in this case, since it's a negative slope, the trade-in value decreases by, and then don't say $1.72, okay? That is not what this means, okay? Certainly your car is not depreciating at $1.72 a year. This is in thousands. So if you take that number, the 1.72, and multiply by 1,000, you're going to get $1,720, okay? All right, interpret the y-intercept if it makes sense to do so. So remember, the y-intercept is the point x is 0, y is, in this case, 21.40. So what would it mean for x to be 0? Well, x is the age of the car. So essentially that means the car is brand new. Does it make sense to talk about the trade-in value or the price of a brand new car? Sure it does, okay? So what this would mean, if the car is brand new, we expect the trade-in value to be $21,400, okay? And again, as soon as you drive off the lot, your car, if it's brand new, loses value. So it doesn't mean you are trading it in. It just means that would be the value of your vehicle should you decide to trade it in. So again, makes perfect sense to interpret it. Predict the trade-in value for a car 3 years old. So again, 3 years old is the value of x. So take our equation from up above and put in 3 for x. And we will find that y hat is 16.24. And again, that is in thousands of dollars. So that would be $16,240 is the predicted value. And then find the residual. So again, that is the error, and that is the actual value, okay, the y value, minus the predicted value, which is y hat. Okay, so the actual value would be that $20,000 that the car sold for. The predicted trade-in value was $16,240 for a difference of $3,760. And what does that mean? Okay, that would mean a 3-year-old car had a trade-in value that was $3,760 more, because it's a positive number, than predicted. Okay. All right, so those concepts from A to H, those are the concepts you need to know for chapter 9. okay? No more, no less. So if you know each of those concepts, you should be able to be given a data set, okay? If indeed you decide that it is a linear set of data, the two variables are related linearly, you should be able to answer all of those questions based on the data you're given.